Right, here we have section 8.6, which deals with vectors and parametric equations. So the objectives here, write vectors and parametric equations of lines, and then graph the parametric equations. So the vector equation of a line is a line that passes through some point parallel to a given vector. Normally it's defined by 2 points, P1 and P2, and so the vector that connects P1 and P2 equals t times the vector a for some real number. So then here's kind of the expanded version. Now in some cases you won't know x2 and y2, they'll just stay x and y, and then t and a1, a1. So t is a number, it's called the parameter, and a is the direction vector. So example 1 here, so write a vector equation describing the line passing through P1, 1, 4, and parallel to a 3, -2. So it's going to look like this. So we're going to have two vectors. So the first one is going to be x minus x1, comma, y minus y1 equals t, then times vector a. So x minus x1, comma, y minus y1 equals t times vector a. So this is the generic formula here, and so it's just everything substituted in, and that's as far as you go. So parametric equations separate the x and the y variables, so both x and y become functions of t. So this variable t, the parameter. So x and y don't depend on each other, only on the parameter, or t can be any number. So here it says find the parametric equation for the line parallel to Q and passing to the point -2, 4. Then make a table of values and graph the line. So your generic ones are x equals x1 plus ta and y equals y1 plus ta. So for x, that's going to become x equals, well, x1 is -2 plus, this is a1 to a2. T times a1, well, a1 is 6, so this is going to be 6t. For the y's, y equals 4 minus 3t, because a2 is -3. So there's the parametric equation. So when you make a table, it's going to have 3 columns, t, x, and y. So we'll just call it 0, 1, 2, 3. So when t is 0, this one's going to be -2. So you're plugging these values in for t's. When t is 1, you're going to get 4. When t is 2, you're going to get 10. And when t is 3, you're going to get 16. And then repeat the process for the y. So plug 0 in. So this is going to be 4, 1, -2, -5. And then these are the values that you'd plot. Once you have your table generated, you only plot the xy column. So let's see if I can sketch this real quick. So -2, 1, 2, 3, 4. 1, 2, 3, 4, comma 1. So on and so forth. It's going to go that way. Okay, so you can also go in reverse. Given an equation, you can write the parametric form. This is actually easier to do. So since parametric defines x and y both in terms of t, the easiest thing to do is just set x equal to t right away. So there's the x equation in terms of t. And then the y one, well, if x is equal to t, I can just do this. Replace the x with t, and you're done. So a parametric form of this line written into equations. All right. And the last example here, so given the parametric forms, go back to slope-intercept. So your x equals -5 plus 4t, and y equals 2 minus 3t. So for this problem, the first thing you need to do is you're going to solve the x equation for t. So I'm going to have to add the 5 across, so x plus 5 equals 4t, and then divide everything by 4. So that's going to make this 1/4 x plus 5/4. Divide, there's a 1 here in front of the x. And then what I'm going to do is I'm going to take my y equals equation, and instead of t, I'm going to substitute in this stuff, what I solved for t being equal to. Then distribute, so 2 minus 3/4 x plus 15/4, and combine like terms. So -3/4 x plus 23/4. So in slope-intercept form means it's mx plus b, so you need the y equals x term comes first, and then the constant. And that's the end of 8.6.